So this is our transmitting end of our circuit, which is powered by a 9-volt battery. And over here we have the aux cord, which is connected to ground, and the red wire is the positive signal, which is connected to a capacitor that acts as a coupling capacitor, and a coupling capacitor filters out the DC portion of the signal, so only AC signal can pass through. And then over here we have our microphone, and a microphone is an active device, which means it requires power supply to be activated. However, it can't take more than 5 volts, so we used a potentiometer to create an output of 4.5 volts. That's then connected to the microphone, and then the microphone is connected to another coupling capacitor, which also acts as the previous one to filter out DC portion of the signal. The next part of our circuit is the summing portion, where the signal from the microphone is summed with the signal from the aux cord. So the signal from the aux cord is going through a 10 kilo ohm resistor, which is then connected to terminal 2 of the op amp, while the signal from the microphone is connected to a 1 kilo ohm resistor, which is also connected to terminal 2 of the op amp. And the op amp is going to be used to amplify the AC signal coming from the summing portion of the circuit. So to amplify the signal coming from the microphone and the aux cord, we put a 51 kilo ohm resistor in negative feedback over the op amp, and that creates a gain of 50 on the microphone signal and a gain of 5 on the music signal. And the microphone signal must have a higher gain than the music signal because the microphone signal is much smaller and must be amplified more. So the next part of our transmission design is the bias T, and the bias T consists of a capacitor for the AC signal, which is coming out of the op amp, and an inductor for the DC signal, which is coming from the battery. The capacitor prevents DC backflow, which protects the signal source, while the inductor prevents high-frequency signal from going to the DC supply. The battery is connected to both an inductor and a resistor, and the resistor limits the amount of voltage traveling into the bias T, so the laser doesn't burn out because the laser can't take a voltage of over 5 volts.
This is the receiving end of our circuit. We have another 9-volt battery powering this circuit. The signal from the laser is captured by this photodiode here, and the DC current is filtered out by this coupling capacitor. The AC signal then travels through this 1.6 ohm resistor, which is connected to a summing amp here. We also have 2 resistors in series that act as negative feedback. This resistor here is 100 kilo ohms, and this resistor is 1.1 mega ohms. They create an extremely large gain of 1 million. The circuit also includes a potentiometer, which carries 4.5 volts to the 3rd terminal of the op amp, which is the positive input. The output of the op amp travels through a coupling capacitor to filter out any excess noise.